All right, good morning and welcome back to pre-calculus here. Today we're going to push a little bit further into trig. We're going to talk about trigonometry. We're going to talk about the ratios of angles in any quadrant. Okay, so my apologies, this book takes things a little bit slow, but that's okay. And I also apologize to my class for the tremendous number of homework problems that they have here. So here we are starting in section, what are we doing here? Section 4.4, I believe. Yep, 4.4. Okay. So the idea here, all right, the idea here is that we are looking at, like, what if we have this triangle, right? Like, or part of a circle, right? So what I'm looking for is, like, what are the trig ratios of this particular angle? Now, the first thing we have to deal with is we're going to have something called a reference angle, okay? And the reference angle, we're just going to drop a perpendicular to the horizontal. It's always a dropping the perpendicular to the horizontal, okay? So no matter where it is, okay, with this angle, actually, let me a little bit better since I have colors. Okay, so if I have, now let's use that color, let's lose here. So if I have this angle, what I'm doing is I'm measuring around that. Okay, there's my angle all the way, almost all the way around the circle. But when I'm looking at my triangle, the reference angle that I want is to the horizontal. Okay, don't go this way. Don't go to the vertical, go to the horizontal. Okay, now it's going to turn out that this angle here, right, is going to be the same, they're going to have the same trigonometric ratios almost as this angle all the way around here. Okay. The only thing that's going to be different is that we have to check out the SIGN signs. Okay, so positive or negative. All right. So little acronym. I don't know. It's weird for some reason. Like, this one bothers me. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But the fact that all of your trig ratios are positive, okay, they're all positive in quadrant 1. Only the sine is positive in quadrant 2, okay? The tangent is positive in quadrant 3, okay? And the cosine is positive in quadrant 4, okay? So the way I learned how to remember this was all students take calculus, okay? Okay, so that's how I remember this one. If you've got another one, feel free. Okay, it's whatever it takes to remember it. That's what I want you to do. The reason why is that sine, right? Sine of an angle is the opposite over the hypotenuse. If we multiply both sides by the hypotenuse, okay, times sine, we get the opposite side. Now, usually we're talking about a unit circle. So the hypotenuse is, that's always 1. So that's the 1. So if I look at the opposite right over the hypotenuse, let me give you a bigger drawing here. Right, there's my angle. Here's my reference angle. Okay, this is 1. Okay, whatever it is. Okay, the opposite side, right, is the y value. So we're usually going to say something like the sine of theta is equal to your y value. Okay, cosine. Okay, so cosine, let's not draw a circle, let's just draw the triangle. Okay. So if I want the cosine of an angle, there we go. Okay. Here's my theta. My reference angle is we're dropping a perpendicular to the horizontal. Okay, it's going to have the same ratios as this angle here. Okay, usually the second angle is phi or phi. Okay, I've always pronounced it phi, but yeah, I don't know. But cosine is going to be the right adjacent over the hypotenuse. And again, we multiply by the hypotenuse. So we got hypotenuse times the cosine of theta is equal to the adjacent side. What's the adjacent side? It's this one, right? So here's my triangle. Here's the adjacent side. So we usually associate the x values. Okay, so hypotenuse is going to be 1 times cosine of theta is equal to the adjacent value. That's going to be our x value. Okay, so hypotenuse times cosine is going to give us our x value. So if you've had the pleasure of, and I hope you haven't, but if you go to our tutoring center, which is very good, they're going to hand you the trig worksheet or the trig things you have to know about trig. And it's a huge page. And don't memorize all of that. How much stuff you already got to memorize? You want to do more? I don't want to do more. So they're going to put a little p here, and they're going to give you an x-y pair. Okay, and these are going to be related to your sine, the pi over 6 angle, your pi over 4 angle, your pi over 3 angle. Okay, but then they're going to go in other directions. They're going to go all the way around the circle, and they're going to give you all these xy pairs for all of these things. Like, don't memorize all of them. Memorize your first quadrant. Okay, memorize this part, and then apply the correct SIGN, the correct positive or negative to what these numbers are everywhere else. Okay, because it's overwhelming to look at that number and say, oh, well, I'm just going to memorize a unit circle. That's how I learned trig. Was they said, here, memorize all of this. And I mean, I tried, but I didn't do it. Like, every one of those quizzes I took was dismal. Okay, and I don't want you to have to go through the same experience for that. So memorize the first quadrant and then apply your SIGN signs, okay, to the rest of it. Okay, so you only have to memorize a couple of few nice things here. Even when I say memorize, like, you should memorize them. They do make your life easier, okay, because later on you're going to be dealing with with calculus problems, and you might have to, like, well, we're gonna figure out the, here's a cosine, okay, and we'd like to know, we're going to take part of this cosine thing, so we're going to take what this, like, frustum type of thing is, we're going to rotate it around an axis here, because we want to figure out the volume of, like, this little piece here. And it's real easy. If I know this is pi over 6 and pi over 3, it's real easy to know what two values I'm going to be going from without having to look it up. Okay, so most of the stuff that we're trying to teach you in this class, and we say this is important for you to memorize, it's just that this is all going to be a part of a much bigger problem in calculus. And if you're looking at all of this stuff up all the time, like if you guys play music, okay, if you read music, not necessarily if you play it, but if you're sitting here looking at, well, this is every good boy does fine, and you're calculating your notes this way, like this F, A, C, E, and you've got to go through each, again, I don't read bass clef. I would be here with bass clef, like this one is this one is that. If you have to go through all of your notes to do this, like any piece of music, like anything more complicated than Twinkle Twinkle Little Star, you are going to be here for a while trying to figure this out. And each of these problems, this one piece of music is going to take you hours to sort through. Same thing with a calculus problem. We're going to give you a bunch of stuff. And if you have to go through and look everything up because you don't remember the particular identity, it's going to take you hours to do this. Okay, now there's some, there's an x cubed plus y cubed. Like, you need to factor this. Like, all we want you to do is, it doesn't come up often enough to, like, warrant you memorizing it. Another reason I know this is because I teach intermediate algebra, and that's when I had to memorize it. Until then, I was like, that's factorable. all you have to do is remember it's back. It doesn't come up often enough to say, oh, this is something I need to carry around forever. Okay, if you want to be a math teacher, yeah, good luck. You have to carry this around. But if you are just trying to do calculus problems, this comes up once in a while. So being aware of like, hey, that works that way. You don't need to do. All right, let's get to the point where you actually tuned in for. Actually go through your homework, because that's probably what you want. Okay, so let's go ahead and do that. All right, so fill out the ratios. Okay, you guys, you should know this by now. Okay, if you've done a few problems, right, you know the sign is the y value, right, over the r value. Okay, the opposite value, and you can draw the picture, like what does the opposite value look like, right? Here's the opposite. Oh, that's y. Okay, so that's where they're getting these things from, is they're drawing a triangle and they're looking at, assuming that r is going to be 1, or assuming that you're not going to have to deal with it too much. Okay, r times sine theta, you know that that's going to be your opposite side, which is usually your y value. Okay, cosine is going to be x over r. Okay, tangent is going to be y over x. Hey, that reminds me of a slope, right? Tangents are slopes. Okay, cosecant, that's r over y. It's the reciprocal thing for the sine. Okay, secant r over x, it's reciprocal for the cosine. Okay, and cotangent, we don't use cotangent all that often, but it's x over y. Okay, it's just the reciprocal values for this. And say, yeah, I think we're good, unless I made a mistake by filling one of these things in wrong, we're set. Okay, so that's where they're getting these xy pairs from. Okay, you could draw the circle, inscribe the triangle, and then see what the two sides look like. All right, that's what I recommend. Okay, we just talked about this. What SIGN are they in the thing? All right. Okay. So this is just another way of pretty much doing the problems that we did in the previous section. Okay, so we have the point -8, 15. Okay, so this is not a unit triangle, unit circle. So the x value right here, 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so we're at 8, 15, we're up here. Okay, what we want is, okay, what we're really going to be doing, the goal is we want the trigonometric ratios of this angle here, but this angle is going to be very, if I'm just going to draw it like in the first quadrant, okay, if I just draw it in the first quadrant, draw the same angle, okay, pretend it's going to be the same. Okay, I'm trying to draw the same thing here. That's this angle right here. Okay, that is the reference angle is this guy. So that's why the reference angle and this angle, they give us the same trigonometric functions, because it's the same triangle, it's just flipped. All right, so we know this is going to be 8, okay, and this is going to be this y value here is going to be 15. What we really need to do is figure out the hypotenuse of this triangle here. Okay, so let's see. Okay, so to figure out our c squared, we have, this is -8 squared plus 15 squared. Okay, be careful in your calculators. All right, if you type in -8 squared, you know that the squared is a positive number. You know that this is positive 64. So don't blindly believe your calculator, because it's going to lie to you about this. And then 15 squared, that's 225. So we have 64 plus 225, that is equal to 289. And I believe the square root of that is 17. Oops, equals 289. Sorry. All right, get rid of all of that. Square root of 289. There we go, 17. All right. Just double check it. So we have square roots 2, 8, 9. Boom. Okay. When I took high school algebra 2, I had a teacher that said, you have to memorize all your squares up to 25. So that's what we did. And we have a quiz on it. I didn't do that badly, mostly because I figured out like I used to swim, used to do a lot of swimming back then. So the only thing to think about while you're swimming laps is multiplication. So that's what I would do. So actually I had a student, so oh, that's brilliant. You actually can figure out how to make cardio not as boring. I guess. All right, what's our sign? Our sign is 15 over 17. These are both positive. This one, by the way, this is always positive. Okay, this is always distance. Okay, it's always, your hypotenuse is always greater than 0. Okay, your cosine though, right? We're going to be putting it in a context. So the cosine is negative 8 over 17. So the cosine could be negative. 17 is positive. Tangent. Okay, that's going to be 15 over negative 8. Does it matter where I put the negative? No. Okay, cotangent is just the reciprocal, so that's negative 8 over 15. Secant is just the reciprocal, so that's 17 over negative 8. Okay, and cosecant is just the reciprocal, that's 17 over 15. Notice which two trig ratios are positive and which ones are negative. We're in quadrant 2. Does it make sense that the sine and cosecant are both the positive ones, everybody else is negative? Okay, so we go through and type that in. What do we got? We have 15 17ths here. We have negative 8 17ths. All right. Tangent was what? 15 over 17? 15 over 8. Negative 15 over 8. And then cosecant is 17 15ths. Why did they change that difference? This was negative 17 over 8. Okay. 17 over 8. And then this is negative 8 15ths. Right? Let's see if we're good. Fingers crossed. Okay, we're set. All right, so that's the kind of thing that they're going to ask you to do. And again, most of these problems, the reason why there's so many of them, we're just getting you used to the idea behind this. Okay, so that's hopefully shouldn't be too mad as far as how to do this. All right, this took me a while to figure out. Okay, because they didn't show us this. Hopefully this will help you. We have to do 5 pi over 3. And your first thought may fairly be, I don't know where the heck that is. That's fair. I know where pi over 3 is, but I know this one's pi, right? Halfway around the circle's pi. Well, fancy way to write pi is 3 pi over 3. Okay, whatever the denominator is here, we're going to say it's that many over this. So this top half, we have to divide this into thirds. Okay, so if you've ever had to like work at a place that serves a lot of pi, right? Your pi being this kind of pi, not math pi. Okay, you know how to break this up into thirds. Okay, and then this is 1 pi over 3, 2 pi over 3, 3 pi over 3. Right? These are not drawn to like scale. This is just a mnemonic device here. Okay, this is going to be 4 pi over 3, 5 pi over 3, and then 6 pi over 3, because that's 2 pi, right? So 5 pi over 3, oh, it's this one right here. So here's my 5 pi over 3. Okay. Here's my 5 pi over 3. That's this whole angle here. This is 5 pi over 3. What's my reference angle? How much more do I need to go in order to get to this, to get to the horizontal? And that's going to be 2 pi over 3. I'm sorry, not 2 pi, 1 pi over 3. Okay, 3. Now you'll notice if I take this triangle and flip it, we're going to be looking at this triangle. So that's why the trig ratios are going to be the same value, numeric value, but the signs are going to be different because this is in quadrant 4. Okay, so the y value is going to be negative, the x value is going to be positive. Okay, so if we just flip this thing up here, we're really working with pi over 3s. Okay, so we could say, well, they're going to make us do those 6 trig ratios. No, they didn't do that. Let's find out what they want. So that's pi over 3. Okay, because we're flipping it from the 4th quadrant into the 1st quadrant. We're not really doing that, but I don't have the whole thing memorized. I have the 1st quadrant memorized. So I'm going to use tools to make sure that I can get the 1st quadrant stuff done, and then I'll just adjust rather than memorize it all for everywhere. All right, so that's what we're doing. Oh, we just want us to, okay, we're just practicing this. Okay. Negative 2 pi over 3. We got to go around the other way. Right, so we're going around this way. So again, we have negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3. Notice that positive pi and negative pi are the same angle. Okay, so negative 2 pi over 3, that's here. How much more do I need to get to this? Or if I flip it to the first quadrant, okay, what's this angle going to be over here? This pi over 3, right? Opposite angles. So this guy here, this is pi over 3. All right, so that's my reference angle. Okay. Ooh, 13 pi over 4. Okay. So it's kind of like an analog clock. So if you're good at doing clocks, these should be okay for you. So here's pi over pi, here's pi, this is pi. This is 4 pi over 4, right? Oh, by the way, pi over 3, remember that's 60 degrees. Pi over 4, that's 45 degrees. Okay, so here we have 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. All right, and we have 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. This is also equal to 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, 13 pi over 4. So what angle are we actually looking at? We're looking at, well, we went around, and then we went around almost, well, we went halfway around. Okay, so the angle we want is this whole piece here. All right, what's my reference angle? Well, how much further do I have to, how do I get back to a horizontal? I have to go back pi over 4. It's also opposite angle, right? That's pi over 4. Okay, if they're, almost everybody takes a little bit of time to get used to the idea of reference angles and how that works. So if you're looking at this and like, this is difficult, like, yeah, it is. Okay, I mean, it isn't, but it does take a little bit of getting used to. Okay, I'm going to cheat with this one a little bit. We have negative 19 pi over 6. Okay, what do I know about one rotation? One rotation is 12 pi over 6. Okay, remember doing coterminal angles? It's the same idea. Okay, so really what I want to do is I want to take out 12 pi over 6 to see where we actually are. And I think this is going to be negative 7 pi over 6. Okay, so all we're doing is we're removing one rotation rather than count all the way around the circle twice. Okay, I'd rather only count it once So we're just going to, we're going to know, like, oh, we've gone around once, and now we have to go around negative 7 pi over 6 more times. Okay. So again, this is 6 pi over 6. Okay, so we have 1, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6, negative 5 pi over 6, negative 6 pi over 6, and then negative 7 pi over 6. Yes, I know that they reduce. Okay, so that's kind of like a checkpoint, though. All right, we know that negative 3 pi over 6. That's negative pi over 2. That's 90 degrees. So that's just kind of a check of like, where am I? Am I on the right trail here? Okay, so I'm not really interested in reducing so much. I'm interested in just using this to be able to count. Okay, so here's my negative pi over 6. What's my reference angle? How much more do I have to go for this? Right, and that's pi over 6. Could we mirror this thing and put it over here? Just flip this thing over to the other axis. What is my angle here? It's pi over 6. That's your reference angle. We're going from this value back to the horizontal. How much longer did it take us to get there? It took us pi over 6, distance of pi over 6. All right, so we're going to say pi over 6. All right. And yes, honestly, everybody who does this, it takes a little while to get the idea of reference angle. If you're like, I'm not getting it that fast, like, you're not alone. Okay, most people take a little while to get this. All right, let's see what we have. I'll tell you what, we are going to go ahead and make a part 2. So this will be section 4.4 part 1, and then we'll do a part 2. That way it won't be too long. In the next video.